Hello, ladies and gentlemen. I'm very glad to welcome you all to our next webinar by NAFTA College. My name is Vladimir Krychevsky. I'm a NAFTA College lecturer and reservoir engineer in Sofoil. Thank you again for joining. Let me remind you how our webinars work. So we are streaming the webinars via YouTube. And in our YouTube channel, you're going to see a chat on the right. So whenever you feel like asking a question, just type it in the chat. And once the speaker finishes his story, we will go into Q&A session, and I will try to address all your questions to our speaker. For those of you who are watching it in record, please keep in mind that we have a website, nafta.college, and there is a forum on that site. And we have a dedicated topic on the forum for each webinar. So if you still have some questions and you're watching it in record, you can just visit our forum and we can keep communicating there. Right, so life is beautiful and amazing. It's finally, it's spring in Russia. Sun is shining, snow is melting, and we feel like conducting another webinar. So our speaker today is my friend and colleague, Dr. Danila Gulyaev, and he is gonna talk about tracers versus PCT, pulse code testing, how to scan your reservoir fast and accurately. Danila, how are you doing?
Good, thank you.
Very nice. Well, I think we're good to go. Danila, the mic is yours. You may now share your screen and have a good webinar.
Thank you. So I'll share the screen and start presentation. So actually there are two main ways to understand reservoir connectivity and formation properties between the well. It's chemical injectors, chemical tracers injects and trace how they go through the reservoir from injectors to producers, and pressure interference to change the pressure in one well and determine the pressure propagation in the other well. So we have decided to compare those technologies and to see what's the advantages of each of them. And the goals of the test was to compare deliverables from pressure pulse code testing and chemical tracers in different cases with difficult geological and production complications. So we have examined only 4 cases. It's the presence of improbable fault, a presence of fault which is not isolating the reservoir, significant vertical heterogeneity of the reservoir, and complex interference of injectors and producers. So let's see how our study has been performed. We have taken a part of geological model and did the simulation of pressure propagation and tracers propagation in case of different complications. So here we have 3 wells, 1 injector, number 19, and 2 producers, number 20 and number 14. And we have an inflammable fault through the whole reservoir between well 19 and 14, and typical properties of the reservoir and fluids. So we have oil 8 times more viscous than water, standard reservoir pressure for the depths of 100 to 1,200 meters. And distance between the wells was little less than 400 meters. And permeability is around 70 millidarcy in average. So firstly, we designed and modeled pressure pulse code testing. So we have this is production history and injection history of our 3 wells versus time. And in the middle of the test, we have shut it and opened our injector for 10 times to create the pressure pulses, which propagates through the reservoir, and measured the pressure in the offset wells. So in the well number 14, which is beyond the fault, we will not see any pressure changes. In the well number 20, which is not isolated by the fault, we would see pressure changes. And the time of the pressure propagation would depend on the reservoir diffusivity, and the amplitude of the pressure changes in the observation wells would depend on reservoir transmissibility. So from those parameters of time and amplitude, we have calculated reservoir diffusivity and reservoir transmissibility, and compared this data with the actual numbers we got in reservoir model. And you may see that this is the same, more or less the same values of reservoir properties between well number 19 and 20. And of course, we cannot assess that properties between number 19 and 40 because there is a sealing fault between them. And we have modeled the tracers propagation through the reservoir. And we may see that the tracer would go from the well injector well number 19, and it will go to the well number 20, and it will not go to the well number 40 due to the sealing fault here. But the time of tracer traveling through the reservoir was about 5 months. So what results of such actually the first and simple test? That both tracer and pressure pulse code testing are good in terms of understanding the location of the sealing fault, and they both found the fault, and also it was possible to assess reservoir permeability between the wells number 19 and 20, which are not isolated by the fault. But pulse code testing would provide better match with actually known in the model value of permeability. From the diffusivity and transmissibility, which we got from PCT, we have calculated average reservoir permeability and connected reservoir thickness, and the values were in good match with the actually modeled one. And from the time of traveling tracer, we have assessed reservoir permeability, and it was bigger than expected because it assumes that the reservoir permeability is same and the reservoir is homogeneous. If we would know reservoir heterogeneity, the match would be better, but in reality, we cannot know that, so we left this comparison as it is. So they both found the sealing faults, and both would be able to find the absence of the fault and assess the permeability. PCT permeability assessment was better, and the time of the test was shorter for PCT rather than tracer, because of course pressure propagates through the reservoir much faster than the actual flows through the same reservoir. So that was initially first test. Now we had a same reservoir model and the same wells, but now the fault is not sealing. It's just there with depth changed in the reservoir. But now the wells are connected. And we have done the same test. Now we may see that pressure disturbance from the generator well number 19 is able to come to both of the wells, number 20 and number 14. And the amplitude of signal in the well number 14 is less than it is in the well number 20. That's why we may calculate reservoir transmissibility and diffusivity between both pair of wells. And now we also see a good match in reservoir diffusivity. And the tracer, now it's able to come through the reservoir to the well number 14 also, not only to the well number 20. And the time is much longer than the PCT. It requires more than a year to the tracer to come from the injector to producers. And the comparison is presented here. Again, we are able to see that the fault is not sealing from both of the technologies, tracers and interference testing. But the tracer would also overestimate reservoir permeability comparing to the actual one. And from pulse cut testing, we are also able to understand what is connected reservoir thickness between the wells, which tracers cannot demonstrate. And we may see that between the wells where there was no fault, our connected thickness estimate was good, but between the wells which has a fault, our evaluation of connected reservoir thickness is overestimated. Why does it happen? Because the injected water here and the pressure pulse here would go both. Maybe I should zoom it actually. Pressure pulses would go here, both here and here, but here we have a fault. So all the pressure which goes here will spread to the three parts of the reservoir and will not be able to go here. And the pressure disturbance will go only through the part of the reservoir, through here. And if we are not taking into consideration that part, our estimation of reservoir transmissibility would be overestimated because we would assume that all the pressure would go and the amplitude of signal which would be less than if there is no fault. So that result in possible overestimating of connected reservoir thickness in the presence of fault which partially sealing. That's the limitation of the technology. So it works fine if there is no fault, and it works good in terms of permeability if the fault is there, and it has a tendency to overestimate thickness if there is a partially sealing fault. But anyway, it's better than the tracer, which do not provide any information about connected thickness. Okay, and the arrival time, of course, PCT would take from 3 to 4 months here for those properties of the reservoir, and it could be even less if we would have better properties of the reservoir. And tracer requires for more than a year to test. Okay, the next case is vertical heterogeneity. If we have, for example, non-homogeneous reservoir with significant contrast in reservoir permeability, we had a model with a thin high permeable layer at the top with the permeability 10 times higher than the permeability of the main part of the reservoir. And we have chosen the homogeneous reservoir of lateral property distribution. And we have also injector and the producers with the same distance from it. Then what would we have? We also have created the pressure pulses in the generator well in the center and measured the pressure disturbances in the observation wells. And from the time and amplitude of the signal, we have calculated formation diffusivity and transmissibility and compare it with the model 1. And it's more or less the same. And the time of the test was for 4 months here. And we have injected the tracers into the injection well. Now, of course, the tracer goes much faster in the high permeable layer, and it goes slower in the low permeable layer. So the first arrival of the tracer to the producers was 14 months here. And the results from the diffusivity and transmissibility from PCT, again calculated reservoir permeability, apparent reservoir permeability, and connected reservoir thickness. And they also was pretty close to the permeability and thickness in the model. And the tracer permeability, of course, was much overestimated, because we have got the tracer arrival time through the high permeable layer, and assuming that it goes through the whole thickness of the reservoir, whole 20 meters. That's why we have significantly overestimated reservoir permeability. And the time of the test, of course, is much shorter for pressure interference than for the tracers. So in the case that we have high heterogeneity in vertical permeability, interference test provides much more reliable information than the tracers. Okay, and last but not least, the case of complex well interference. For example, we have one producing well in the part of the reservoir and 2 injectors, W in the EE1 and WE2. And the closed injector is 1 and the far injector is 2. And we have wanted to understand the reservoir properties between the farthest injector and the producer. So what would happen in such situation? We have changed the pressure in well number 2, injector number 2, and created the pulses of pressure by changing the rate of that well. and measure the pressure response both in injector 1, which is closer to that well, and in producer of P1, which is farther here. And we assess the reservoir properties, diffusivity and transmissibility from those pressure pulses. And we may see that it's pretty close to the reservoir properties which we used in the model. Good match on diffusivity and also good match on transmissibility. We also created here 10 pulses during 4 months. But what would happen if we inject tracers? Here we have injected tracers to the both of the injectors, WE1 and WE2, and marked it with different colors, red and blue. And because the injector rates are the same and pressure increase by the both injectors is the same, the tracer from the closest injector would be able to finally go to the producer, but tracers injected into the well number 2 would never be able to go to the producer. So the tracer would demonstrate there is no connection between well number 2 and well OP1. And in reality, of course, there is a connection. So if we assume that our generator is well injector 2, tracer would show no connection between them because we'll never get the tracers go from the farthest injector due to the presence of the nearest injector. But of course, this well supports the pressure in the production area. The injection of this well, of course, supports the production in the producing well. And pressure interference would be able to demonstrate that there is a connection. And when we have calculated from diffusivity and transmissibility, apparent reservoir permeability and connected reservoir thickness, it was a pretty good match with the actually modeled one. And of course, pressure interference would provide the unit rate pressure impact from the injector to a producer, and it also has pretty good match with the modeled one. So what can we summarize? That both PCT and tracers are good in terms of understanding reservoir connectivity. They both would provide us information about the faults, are they sealing or not. But the time of test of PCT is much faster than the time of the tracer stage. In terms of vertical heterogeneity, arrival time of a tracer would be much higher in terms of high permeable thin layer, and that results in overrating the overall formation permeability from the tracer. But PCT would provide the right assessment of the reservoir permeability, and additional information would be connected reservoir thickness of the reservoir from this test. And if we have several injection wells, then the tracer will not demonstrate the connectivity between the farther injector, which is farther from the producer, due to the pressure impact of low injection well, which is closer to the producer. And that will not be a problem for pressure interference. If the wells are connected, we will be able to see the connection anyway, and we will also be able to understand the reservoir transmissibility and diffusivity. So that's all I would like to share about the comparison of those two technologies, and I will be happy to answer your questions.
Thank you very much, Danila. I think that was a comprehensive study. You showed several interesting cases. So let me sum it up. If I got you correctly, in simple cases, tracers, both tracers and pressure study is fine. It's just in many cases, tracer study would take more time. That's point number one. Point number two, that in a complicated environment, I mean, if we have a heterogeneous reservoir, and if we have a weird injection pattern, then even if we don't get the tracer, it doesn't necessarily mean that the wells aren't in communication. That's point number one. But even if we get the tracer and we try to estimate the connectivity, we might get it wrong if the reservoir is heterogeneous, right?
Yes, if we have a significant difference in vertical heterogeneity of the reservoir.
Yeah, okay. Thank you very much. Okay, ladies and gentlemen, if you have any questions, any opinions on that, please, the chat is yours. I see there's already some discussion in the chat, but first, I would like to highlight one more thing. So in this study, we are, we are doing it like academically. So we are focusing on methodological issues of tracers versus pressure studies, but there's also a technological issue. So, well, in my experience, there's another problem with tracers that, well, you know, when you work with pressure studies, pressure interference, that is something that we may always check. So, I mean, the clients, the oil company, they see the pressure. And that is something they can see and double check if there are any doubts. Unlike the situation with fluid samples, which we, well, often we pass them to the lab and we can't control the lab, and there is a little question, a slight question on reliability of the tracer studies. Do you have an opinion on this?
Well, yes. In terms of pressure interference, any producing company engineer could examine the results, because service company will provide this pressure record. But in terms of tracers, only the service company would be able to detect a small concentration of the tracer in the producing probes. And there is no solution of that. We may just trust the service company, and that's it.
Okay, I see. Thank you very much. All right, so let me look at the chat again. So there was already some discussion, and I see some questions, and I already see some answers. So, okay, so let me rephrase a question from our friend from Dubai. Well, in your studies, you are showing the PCT where you pulse for like 10 cycles. And well, it looks like a little overkill. So the question is, how do we optimize the PCT cycles, the PCT duration?
Yes, very good question. Let me go to any of the example, for example, here. In ideal world, actually, we may have enough only for one cycle. If we know everything, if there is no noise, no pressure disturbances, then we can change the rate of the well and see the response exactly in the other wells. But in real life, we may have a significant noise. We have other wells that may change rate, which also would result in pressure changes. So if we have only one disturbance in our generator, we may see several disturbances from different wells in our receiver, and that would lead to a significant uncertainty in the reservoir parameters that we got. To avoid this, we create several pulses, and the more pulses we would create, then the more reliable result we would get. And actually, the longer would be duration of each pulse, then the higher would be the signal response in our receivers. The model case, so we were not actually borrowed with that. We just created a 10 pulse with the maximum possible amplitude we can, and see quite big pressure responses here. It's up to 2 atmospheres. In reality, we may minimize the time of the test because by using very sensitive pressure gauges. And in the real life, we always do the preliminary design of the test to see what would be the minimum duration of the whole test to be able to detect the signal with the best gauges possible, because the lower the time of the test and the faster results we would be able to provide. And usually we avoid having less than 6 pulses because if we, for some other pressure disturbances from the other wells, due to that we would lose some of the pulses, then our solution would be less certain. So we, and the duration of each pulse, we model and choose the best one, which is possible to detect. That's the first part of the test design. And then we add the noise, which we usually have from the operator company on our signal, and do pulse code decomposition. So we have analyzed the designed response to get diffusivity and transmissibility, and compared the values that we got with the values that we used to do the design. And also we eliminated some of the pulse at the beginning, in the middle, and in the end, and do the same procedure at the noise, and also do the interpretation. We call it cross-validation. If we use only part of the curve and got the same result as we do it by using the whole curve or other parts of the curve, then it means that our design provides reliable information, and we may go with this program to the real field, and we will be sure that our results would be reliable. So to get the optimum design, we spend a lot of time and effort to be sure that our results that we would get would be actually the reliable one.
Okay, thank you very much. I think that does it. We have another question. So you used a dynamic model in order to perform this study. So the question is, which software did we use, and what was the grid size in the model?
Okay, for reservoir modeling, we used T-Navigator. For interpretation results, we used our own software Polygon. And the size of the cells, I think it was about 40 centimeters to the ZX and about 50 meters to the X and Y axis.
Okay. And we did use LGR, did we?
Yes, and we did use LGR around wells. Yes.
Okay. Okay, thanks. Thanks. Another question is on the limitations or constraints of PCT. So if you see any obvious limitations or constraints, could you please elaborate?
Limitations of PCT. Well, first of all, we must be able to measure the pressure. So we must be able to install the pressure gauge downhole to be able to detect the pressure pulses. And we have an additional limitation of the time. If the reservoir properties are low and distance between the well is too far, then it might happen that the duration of the test should be incredibly low or incredibly long. Maybe if we have 1 millidarcy and 5 kilometers between the well, maybe it would require a year to do the test. So it's not possible to do it in a reasonable time. But in most of the cases, a few months of the test would be enough. Actually, we had cases when there were only 2 weeks, and had cases where it was up to 4 months. Standard procedure is 1-2 months.
Okay, thank you very much. We have another question. When we variate the injection rate in a generating well, how it affects the production in offset producers during the test?
Well,
does it or does it not?
It may affect, but usually not much. For example, in those designed cases, it didn't affect the production at all. We have just increased the drawdown by 2 atmospheres, and after that, our production would remain the constant. So we have just increased the drawdown. But in real life, yes, it may result the slight production decrease, but it will not be more than 5%, I suppose.
Yeah, okay, I see. So, I mean, extending this question, our guest is asking, so during the PCT, we need to reduce injection. So, I mean, for the period of the test, the overall cumulative injection would be less.
Yes.
And it could lead to some deferment in our production. So the question is, how do our clients react to that? Is that an issue?
Well, anyway, it's not actually a big production deferment. Yes, we would decrease a little bit of reservoir pressure, so it results in a little bit decrease of drawdown and a little bit decrease of production. May result, that depends on the pressure support from the other areas or aquifer or whatever. But anyway, it's maybe 2000 times less than the production deferment for the standard pressure interference test when we shut the observation wells, wait until the pressure stabilized, then create the pulses, then looked at those pulses and the observation wells, and then start them again. That would be a huge production deferment. Actually, that's the limitation of pressure, standard pressure interference, and the reason why it doesn't used widely, despite it was firstly tested more than 60 years ago. And if we do this pulse code testing instead of standard pressure interference, we avoid such a problem with production deferment.
Okay, thank you very much. We have another question, actually a very nice one. Yeah, because when you perform this design, perform this study, you use a very classical way of pulse code testing. So you have absolutely equal cycles and equal rates. And our guest is saying that would we recommend to have different durations for each cycle and probably different production or injection rates for easier identification during analysis? What do you say to that?
Yes, it's just again an ideal case of part of the reservoir model when we actually know everything. But in real life, it's not always like that. So to make our pressure code more reliable, we usually do each of the pulses significantly longer than the other pulses. But we design it, and that's why from that pulse, our response would be higher and longer than response from the other pulses. And that avoid us from the possible mistakes in understanding which pressure response corresponds to which pressure disturbance. Yes, we usually do that, but in almost all the cases that I have examined and interpreted, such situations compares not intensively. So due to some field operation problem, some pulses would be longer and shorter, and because the producing company is not always strictly follows the pulse code testing plan that we have done for the test. So in anywhere, our code becomes much stronger during that issues. So that's actually a situation when the problem becomes a solution.
Thank you very much. Thank you very much. Another question regarding PCT. So when we analyze the PCT results, do we, at any point, do we use a rate? And how important is it to have accurate rate measurements?
Yes, to have a reliable interpretation, we must use actually not only the pressure, but the rate of the generator well and the observation wells, both of them. And the ideal case would be have the specific rate management measurement at the end of each cycle, and every 2 hours rate measurements in the producing and injector wells. But in reality, we will not always have such information. But what we do is rate reconstruction. For example, if we have at least 3 rate measurements in during the pressure pulses, and we have a bottom hole pressure records. And if we assume that injectivity index is constant during the test, we may recalculate the rate on base of the rate measurements that we have in several situations, and then use the correct rate for the interpretation of the test.
Okay, thank you very much. Thank you very much. So I don't see any more questions in the chat. Let me ask another one from me. So we've been talking a lot about differences between tracer studies and pulse code testing, and the whole topic was investigating cross-well connectivity. And yeah, of course, it's very interesting. But from your experience, what would be the benefits, the most beneficial situations where you need to understand cross-well connectivity, and how do you apply this information to oil field management?
Well, the most important situations where we must understand reservoir connectivity is actually the start of pressure maintenance system implementation. If we would inject water or gas in the well, which is separated by sealing valve from our producers, then there would be no benefit from injection at all. And that's why the most important situation is where we need to understand reservoir connectivity is the start of pressure maintenance system implementation. And if we have already started it, but field doesn't respond as it should be, we still have production decline, and then those tests can be used to understand what is going on, why some wells are not efficient, why we still have production decline, and if we have water cuts, too fast increase of water cut, then we may understand why does it happen, which wells are not injecting water into the production area, and which wells are injecting water which goes directly to the producers, so that the pulse cut testing is the right technology to have additional oil from the same fields. And the second very popular situation where this test could be useful is if we have a long production history, which was not recorded very accurately in the many years ago. So if we assume that there's still a lot of reserves somewhere there, but we are not completely sure where they are, and would like to do infill drilling, but we are not 100% sure that it would be the right place, maybe this area is already water wet, then we may do pulse cut test to assess average reservoir saturation between the tested well. And if we would see that there is still a lot of oil there, then it would be safe to drill a well there. So additional big application of PCT would be safe, create a safe assessment on infill drilling, producing well.
Okay, I see. Thank you. So, and what if we have, well, for example, a greenfield? We only have several wells. We are not planning any water flood, but let's say we are not sure about compartmentalization of the fields. Do you think PCT can help? And can we use producing wells as generating wells in the test?
Yes, if we have a green field, of course, PCT will also provide the same information as it always will. transmissibility and diffusivity of the reservoir, and connectivity between the wells. But if we are not planning to do pressure maintenance system, that information will only improve our understanding of the reservoir and increase reliability of our forecast of production. So it will not result in immediate additional oil right after the test. It just make our understanding of the reservoir much better, and that's it.
Okay, I see. And so what about using the producing well as a generator?
Yes, it's possible. I think about 25% of the tests we have done were done with the producing well as a generator well, because the pressure disturbance may be created not only by injecting and shutting the injection wells, it could be done by choking up and down the producers. But still, most, 75% of the PCT are done with the injector well as a generator well, due to economical reasons. If we open and shut the injector, our production deferment is very minor, maybe zero, maybe very small. But if we choke up and down our producer, we would have a production deferment in the generator well. So that's why if the producing company has an injector in the area of interest, it would be more economical to do the generator well and injector well, because that would result in absence of production deferment.
Okay, I see. Thank you very much. But I mean, returning to our topic, like traces versus PCT. So if we need to perform the cross-well connectivity study, we may do it with PCT using producing wells. And this is something that we cannot do with tracers. So
Yes,
that would be
true.
another advantage of pressure testing.
Absolutely, yes.
Okay, I see. All right. Ladies and gentlemen, I think I don't see any more questions. And I think that was a comprehensive conversation. I would like to thank Danila Gulyaev again for these brilliant slides, brilliant story, and thank you very much for answering all those questions. Again, if you are again watching it in record and you feel like asking another question, then please, I welcome you to our forum, nafta.college. We can find the topic regarding today's webinar and ask any questions, and we will answer you as well. So thank you very much for taking your time. I welcome you to our next webinars. Please look at our schedule, our agendas, and I would like to wish you all a good day, good luck, and see you again. Thank you very much.
Thank you very much.